Welcome back. We're going to pick up right where we left off from the previous lecture. So we left off with this big takeaway that if we have some starting amount of something and we have to multiply it by some number over and over and over again, like double it every year or take it down to 90% of its previous value every year, every week, we have to multiply by that same factor over and over and over again. The way we achieve that is we raise that factor to an exponent of however many times we've multiplied it, and then multiply that by the initial value. And again, I said it in that order, doing the b to the x first and then the a, because that's what the order of operations forces you to do. Exponents come before multiplication. That's the way we want to do it, even though we usually write it with the initial value first. Great. But I have never heard somebody say, man, my car really holds its value every year. It's worth 92% of what it was worth the year before. That is not the way people talk. People would say something like, my car loses 8% of its value every year. I've never heard somebody say, man, I've invested in a great investment. Every year it's worth 110% of what it was worth last year. That's not what we say. What we say is it's gaining 10% a year. So what we're typically referring to is not the actual factor we see in the equation, but the change, the amount of growth or decay from what it would have been if it stayed at 100%, 100% minus 10% or plus 10%, as the case may be. So let's look at this example here. Every year my savings account is worth 5% more than it was worth the year before. I've got $1,000. Year one, I had 5%, and I've got 1,050. Year two, I had 5% more, and I've got not 1,100. Again, we're not adding a constant rate of $50 a year. I'm now adding another 5% of this 1,050, which is, take your calculator out, I got $1,102.50. 1102.5. So I'm getting an extra $250, which is the interest on the $50 interest I already earned. At year three, now I'm earning 5% interest on my 1102.50. Now, you might be doing 1102.50 times 5%, which is 0.05, and then adding that to the original 1102.50. That works. It's not the fastest way. What is a single number we can multiply by 1102.50 to give us how much I've got after 3 years, which is 1157.63. What can I multiply by that has the same effect as multiplying by 5% and then adding the total? 105%, or 1.05. What I'm saying here is every year my money is worth 105%, or 1.05 times what it was worth the year before. Take that times 1.05 times 1.05 times 1.05 times 1.05. I can jump out here to 10 years if I just do, let's write an equation here, y equals my initial investment of $1,000. Y equals $1,000 times not 0.05, not 5%. That would be making it shrink. To get the next year's value, I take my $1,000 and I multiply it by 1.05, 105%, and I do that over and over and over again to the power of however many years it is. After 10 years, my account is worth, what'd you get? I got $1,628. Not too bad. After 100 years, let's say you find a bank account that great-great-great-grandpa Myrtle opened back in 1920, put $1,000 in, which had been a lot of money back then. What's that worth now? I got, holy cow. Oops, that was 1,000 years. Let's try that again. Not quite that much. I got $131,000. That's a pretty good return on investment if that is 100 years. Let's move on to our next example. Let's say I've got 1,000 square foot pond. That's a pond about the size of a small house or a large apartment. And it's slowly evaporating in hot weather. Every week, this pond is shrinking by 10%. So it starts at 1,000 square feet. After 1 week, it'd be 900 square feet. After 2 weeks, it would be not 800. It isn't a steady decrease of 100 square feet a week. It's a steady decrease of 10% a week. So what is 900 minus 10%? Now you might be doing 10% of 900 is 90, subtract that, I get 810. That works. But a faster way to do it is just take my 900 and multiply it by the amount that's left over, the 0.9, the 90%. 810 times 0.9, I got 729 square feet. Multiply that by 0.9, I'll get the next one, times 0.9, times 0.9, times 0.9, times 0.9, times 0.9, times 0.9. So in general, I'm doing my 1,000 square foot pond times 0.9, the power of however many weeks have gone by. X in general, or 10 if I want to make it 10 weeks, or, well, what is it after 20 weeks? I mean, is it essentially gone after 20 weeks? That's almost half the year. I would expect it to be gone. 0.9 to the 20th times 1,000. And I got that pond is, well, still 121 square feet. So it's a puddle at this point, but it's still there. Let's do that where you can actually see my calculations. 0.9 to the 20th times 1,000. It's still a 100 square foot puddle at that point. Moving on. So what we've been talking about here is a distinction between a growth or decay factor, which is the number you actually have to multiply by to get the next number in the equation, versus the growth or decay rate, which is what ordinary people would say when they were talking about whatever this situation was. You wouldn't say every week the pond is 90% as big as it was the week before. What you'd say is, if you said anything in this line at all, is pond looks like it's shrinking about 10% a week, or my car is worth about 8% less a year, something like that. So the factor has to go in the equation, but the rate is what we actually say, and they have an incredibly simple connection. Resist the urge to overcomplicate this connection. B, the rate that actually goes in the equation, the factor that goes in the equation is simply the rate plus 1. That's it. That 1 you can think of as 100%. So if it's growing 5% or 0.05, add 1, I get 1.05. If it's shrinking 10% or negative 0.1, add 1 and I get 0.9. 1 minus 0.01, 1 plus negative 0.01 is 0.9. So just take your 100% baseline, that's the 1, plus or minus the rate. Plus if it's growth, minus if it's decay, which it'll be negative. Think of it as negative. So you're really just adding either a positive growth rate or a negative decay rate to get the growth or decay factor. Moving on. Let's go ahead and pause the recording here, and I'll take it up again with one more recording to cover the last couple of the last 3 slides in my